Hey everyone, welcome back to my channel Electric, where we break down complex electrical concepts into simple, engaging ideas. Today we are diving into a fundamental yet often misunderstood topic: why do some circuits require grounding and how can it be done safely? Grounding. It's that third prong on your plug or that wire you see connected to a rod in the ground. But what's the big deal about it? Why is grounding so crucial? And more importantly, how do we do it correctly? Let's get started. Let's start with the basics with what is grounding. Grounding is the process of connecting electrical systems to the earth. Think of it as giving stray electricity a safe escape route. When designed correctly, it protects both the system and the people around it. But why the earth? The earth is a massive conductor and it's capable of absorbing and dissipating electric charges safely. This prevents excess current from building up and causing damage or danger. Grounding isn't just a nice to have, it's a must have in many cases. Here are the three main reasons why circuits require grounding. First and foremost, safety. Imagine a fault in your circuit causes the metal casing of a device to become electrified. Without grounding, touching that device could give you a nasty shock. With grounding, the current safely flows into the earth instead of through you. This is especially important in devices with metal casings like washing machines, ovens, and even power tools. Secondly, grounding protects you from your electrical equipment. Lightning strikes, power surges, or even static electricity can damage sensitive electronics. A grounded system redirects this energy safely to prevent catastrophic failures. Finally, grounding ensures circuit stability. By providing a common reference point for voltage, grounding helps maintain consistent operation, especially in large, complex systems. Alright, so now that we know why grounding is crucial, let's talk about how to do it safely. Step 1: use a proper grounding rod. This rod is driven deep into the earth, ensuring good contact with the soil. The material, copper or galvanized steel, both excellent conductors. Step 2: connect your grounding wire to the rod using a secure clamp. Make sure the wire is thick enough to handle any fault current. Step 3: check your connections. Loose or corroded connections can compromise the safety of your grounding system. Regular inspections are key. And a bonus tip is that in large installations, ensure the grounding system complies with local electrical codes. Safety standards like the NEC or IEC provide detailed guidelines. Before we wrap up, let's bust a few myths about grounding. First is that grounding prevents all shocks, which is not true. While grounding reduces the risk, it's not a substitute for proper insulation or circuit breakers. Secondly, any metal can be used as a grounding rod, which is wrong again. Not all metals have the conductivity or durability required for effective grounding. Always use approved materials. So there you have it, the what, why and how of grounding in electrical systems. Grounding isn't just a technical detail, it's a lifesaver and a circuit saver. Now it's your turn. Have questions about grounding, or maybe you have faced a tricky grounding challenge? Drop your thoughts in the comments below. Let's spark a discussion and learn together.